Okay, let's solve this LeetCode problem. I must tell you that this is one of the best LeetCode problems out there, and you'll love it. I believe that you will love it. You're given an n by n grid matrix. You can do the following operation any number of times. We basically choose two adjacent elements of the matrix, and we multiply it by -1. So our goal is to maximize the summation of the matrix, the sum of all the elements in the matrix. That's our goal. We want to maximize that. Okay, let's see what they mean by choosing two adjacent elements. We choose two adjacent element, let's say this one, -1, right? We choose an element to its left, to its right, and up and down. These are the adjacent elements. We choose this adjacent pair, and then multiply these two elements by -1. For example, in this example, they multiply these two elements, 1 and -1, by -1. So then they get -1 and 1. And then they choose the first column and multiplied it by -1. And then they get 1, 1, and 1, 1. They made all the elements positive, and that is the best case. That is the maximal sum. And in the next example, they choose -2 and -3 and multiply it by -1. They get 2 and 3, and they have -1. So there isn't a way to make this one a positive. If we choose this two pair, 1 and -1, again, we would make this positive, and then this would be negative. If we choose -1 and 2 and multiply it by -1, and then we'd have 1 and -2, this makes it worse, because before we have -1 and now we have -2. And if we choose this one here, it is the same case as the above one, the above one that is above this one. So in this case, the answer is 16. Now let's see how I first approached this and got stuck, and then shift my perspective and find an observation. Let's see how I did that. Okay, now let me tell you what I did first. Now, since we want to maximize the sum of all the elements at the end, okay, we might go for the largest negative value in absolute. So this means the smallest negative value, I mean. So in this case, it's -7, right? I said, okay, we have currently this -7 in our sum. Let's just say the currently sum is some value. We do not care about that. And we have inside this sum, it's something like, there is -1 inside this sum, right? So I want to get rid of this -7. So -7, right? So that's the largest negative, the smallest negative value. Basically, it will contribute to the most if we make it positive by swapping any value. So in this case, what you would do, like that, okay, we have 4 adjacent values. What pair should I choose? I said, okay, if I choose this one, currently 4 and -7, this is a sum of 3. If I flip it, I make it -3. If I make it like -7 and 4, right? If I make it 7 and -4, the sum is going to be 3. And right down here, I have -7 and 2. If I do this pair, then I have -7, I will make it 7 and -2. This gives me a sum of 5. So previously it was -5. Right down here, again, we have 4. We know that it will give us 3 if we do this operation over this pair. And now we have -7 and 1. -7 and 1, if we do this -1 operation on this one, we'll have 7, and this is going to be -1. This gives us 6. Then I said, okay, that is my idea. I will choose every time the largest negative value, I will try to make it positive so that it can contribute to the sum the most. And then out of its all pairs, so we have in this case 4 pairs, it might be like in the corner and have 2 pairs. Out of all pairs, I will choose the one which will contribute the most positive value. It contributes 6 to the sum if I choose this one here. right? I will make this 7 and -1. Okay, then I said, okay, let's do that. Okay, let's choose -7 and choose this adjacent pair, and we'll make it, okay, we'll make it -7, we'll make it 7, and we'll make it -1. And then then the next largest, the smallest negative value is -4. And then I said, okay, let's choose its pair out of its pairs, the one that gives me the most contribution. If I choose like 5 and -4, this pair, this is going to be -5 and 4. So in fact, we're making it worse. Previously, this was a sum of 1. Now it's a sum of -1. So we don't want that. And from this -4 and 3, and we have -3, so we have -1. If we flip it, we have -3. We have a +1 sum. And in fact, we have a better approach. Okay, we'll go back, and we have a better approach. -4 and -1, -1. Since we make it -1, then we have -5. We can choose this two and make it 4 and 1. This gives us a sum of 5. That's an improvement. Then we would have here +1 again, and we have here a +4. Okay, let's go back. We have here +1, and this could be a +4. Now we only have this -1 and -3 and -1. Then we just choose 2 and make it positive and positive. This seemed like a valid approach, but as I try larger matrices, then I see that it gets pretty wild, and it's hard to keep track of what is the smallest negative. And if I do, like, imagine that there is a matrix, that there's somewhere I choose my current optimal case. What I consider optimal is I choose the smallest negative value here, and its adjacent value that contributes to the sum the most, and then I do the operation over here. This is negative, this is going to be positive, and this is going to be negative. And then I thought, okay, since this value is going to be negative, now it creates other possibilities to check. And then if I do it for any one of these pairs, then it creates other possibilities. And it gets wild, and I couldn't manage to figure out what should I do in this case. Yes, I could have kept track of this negative values and then its pairs, this idea basically. I could have pursued this idea, but then I actually abandoned it because I couldn't see how I can implement it. And in fact, after I played it like this way, I always see a emergent pattern there. I see that it is always possible to make it either at the end we'll make all the values positive, or we'll end up with only one negative value. I observe that, and then I try to prove it, some kind of like get intuition. Now I'll tell you how I shift my perspective and then see that this intuition is actually correct, and it leads me to another solution that is very nice. Now I'll show you that. Okay, now let's think about something different. Let's do an observation here. Think about a matrix that only have one negative value. Right here. So let's say it's not -1. Say that it is -3. And yes, it has some values adjacent to it. Right? Then this is only negative value, -3, right? So it makes your sum smaller, right? If you didn't have this -3, then the sum would be larger. So you would want to get rid of this -3, but there isn't a way, because if you choose a value, because this is the only negative value, remember this is the only negative value. If you choose a negative value, -3, and a positive value, you'll make this a negative, a positive, the +3, but this value will get negative. So again, you create a negative value. You can keep track. You can keep doing it. Remember, in this case, there is no way to get rid of that single negative value, because an operation, let me tell you what it does. When we do an operation, on a pair of elements, the three things happen actually. The two cases, either these two all negative, these two both negative, then when we do operation on this one, we'll make both of this positive. So then we increase the number of positive values. We actually decrease the number of negative values by 2. If one of them is positive and the other one is negative, when we do the operation on this one, we do not change the number of negative values in the array. So if we had 3 negative values, for example, then if we choose this pair, one of them is positive and one of them is negative, then we do the operation, then again this one is going to be negative, this one is going to be positive. Again, we have one negative, then nothing changed. So this, in this case, we do not change the number of, we basically change the number of negative values by 0. So then the third case is when both of them are positive. When both of them are positive, then if we choose this one, we'll actually increase the number of negative values. Both of them will end up being negative value. Well, actually, we do not want to do that, but I just want to show you one thing that never changed. That is what we call like invariant. You see, the negative one, there are things that change, there are things that get very wild. It's hard to keep track of them, but this is very nice observation. If you have -2, 0, and +2, basically this -2 means that if you do operation, one of this will happen. Either you will decrease the number of negative values by -2, by 2 basically, or you will not change it, or you will increase it by 2. So why do we have this? We have 2 every time we have 2, right? If the number of negative values is, let's say, 3 or 6. In case of 3, if we do any of these operations, if we do this one, if we choose 2 negative values and then we apply this operation, we'll increase the number of negative values by 2. Then you will have 1, right? We have 1. Or if we choose one positive and one negative value and do the operation, we'll not change it. This is the case too. Then the number of negative values will stay same, like 3. We didn't do, like in terms of the count of negative values, we didn't do any improvement. And we don't want to do the third operation because let me just show you that nothing changed. If we do the third operation, we choose 2 positive values and make them negative, and this increased the number of negative values by 2. Then we have 5. We have 1, we have 5, and we have 3. You can see that doing this operation will not change the parity. Basically, the number of elements, is it odd or positive? It will not change. It is odd or even. It does not change this parity. We have odd number of negative values, and doing the operation, after doing the operation, we'll end up with the odd number of negative values. And if we have one negative value, every time basically we just subtract 2 or add 2 to the negative value, or we don't change. If we basically have a single value that is 1, a 1 negative value, there's no way to make it positive and end up with 0 negative values, because every time we're either decreasing it by 2 or not change or increasing it by 2. So there's no way to decrease it by 1. So basically the parity here, that is the invariant. That is something that is not changing. We have 3, we have 1, 5, and if we had 6 even number of odd negative values, then if we applied any of this operation, we would get 4 or 6 again, then nothing changed, or we would increase it to 8. You can see it was even. Previously we do the operation, and any of this case, it's even again. So there's no way, even if it is even, it's 6. So right. So now you have 4. Let's say you decrease it by 2. You can again decrease it by 2, right? There is some kind of there's some way that you can do it. I'm not going to show that what is the specific steps, what is the specific pairs that you have to choose. But if there is for negative values, now you can decrease it by 2. That is always the case. I'll show you why. and then you can decrease it by 2, then you end up having no negative value. All of the values in the array becomes positive. So that is the maximum, that is the best we can do. If it is odd, we can do the same here. If it is odd, every time we decrease it by 2, and then at the end we'll have one element that is negative, and there is no way we can get rid of it. So in this case, what we want to do, since this is a negative value, this decreases the sum. It makes it less. So we don't want this negative value. We don't want this negative value to be too small. If it is like, we don't want, if there is a case that we can end up with -1 and -3, we would always choose this -1, because -3 would make our sum too less, right? I don't know if that is proper to say, but it will basically make it worse. But -1 is best we can do. So basically, when we have odd number of negative values, we can always get rid of the negative values in pairs. We can get rid of 2 negative values every time we do that operation. So at the end, we will end up with a single negative value, and we do not want this negative value to be too small. So we want either to be 0 or -1, if something like that, right? What is this small? Then I'll show you why we do that. If it is positive, if we have even number of negative values, every time we can get rid of 2 negative value, and at the end we'll end up with 0 negative values. This is the best we can do. The array elements will be the sum of the matrix will be the sum of all values in positive, the absolute values. Now let me show you why this is possible now. Okay, we said that when we have even number of negative values, it's possible that the sum is the maximum sum is the sum of all values, where the positive values is flipped to negative values is flipped to positive. So basically, we'll take the absolute value of -7. So in this case, we have 4 negative values. It's -3, -1, -7, and -4. Since we have even number of odd values, it's always possible to make make the sum with all of this positive, all of this values positive. So how it is possible? Let's say this values appear in a row, right, like this, right? Then you would choose this 2, and then you would choose this 2, make them positive. That's possible. But is there a way to make the numbers appear in a row, appear consecutive to each other, like maybe -3 here, -1 here, -7 here, and -4 here, so that we can choose them in pairs? So every time when we choose 2 negative value. We choose 2 negative value. In the pair, we want 2 negative value. Is it possible to get to this point? Yes, it is possible. Remember how we can do it. When we can choose a negative value, we never choose two positive values. We don't want that. So we choose a positive and a negative value. What we do, we make this positive and we make this negative. Now, imagine you have this positive, 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 and a negative, and let's say positive, positive, positive. Basically what we do when we choose this one, we make this negative and we make this positive. And now then if we choose this one, we make this negative and we make this positive. We'll shift this negative to the side. If there's another negative, we can do the same operation again, and we shift this negative and to put this negative values in one place. Basically, we can group the negative values in one place. If we have 4 negative values, we can group them in one place at least. So it does not really matter if we put them in one place. We just want them, 2 of them in pairs. It doesn't really matter where they appear in the matrix. The 2 of them might be here, 2 of them might be here. What I want to say is that it is possible to do this. It is always possible to put these 2 negative values side by side and then choose them to make positive. So if we have 4 negative values, So we basically put them in two pairs, so right adjacent to each other, somewhere in the matrix, without increasing the number of negative values. So without increasing the number of negative values. So I said we do not increase, because otherwise we don't want to do, well, while you're doing this, while you're putting negative values next to each other, you don't need to increase it. You must not increase the number of negative values. That's why we do this operation on a positive and negative. This, as we said, that does not change the number, the parity of the negative values. If we have this, does not change, because when we choose this, it will make it negative and positive. We're basically shifting a negative value around. If we choose like negative, if there was a negative here and a positive here, if we choose like this way, and then we would make this positive and negative, we're getting this negative down. If there was a negative, positive, we'll make this positive by choosing this pair. We make this positive basically, and then we make this negative. So you see, if we have, let me show you, if there's a negative and there's a positive and there's a positive, we basically change this to this operation, doing it on -1, a negative and positive pair, then it's basically a shift operation, which we swap this two values. We have positive and negative and positive, and we change this negative. Okay, it gets a little messy now. Now let's go back up. So we said that when we have even number of negative values, it's possible to put them in pairs. And then once they're in pairs, we can choose these two pairs and these two pairs and make them positive. When they're odd, like in this case it's even, but let's just imagine that they're odd. When they're odd, that there's another odd value here, right? So when they're odd, we can put the 4 of them, we have 5 of them, let's say this was -5. So we can put 4 of them, we did before, we can put 4 of them in two pairs. We can put this 2 pair and 2 pairs somewhere in the array, but we'll end up always, whatever we do, since we're pairing in two, then we have -1 at the -5 at the end. As we said, we don't want this -1. So if we have in the array, for example, a value that is 1, a positive 1, before we making like taking this -5, we better make this 1 a negative, so that at the end we actually end up with -1, not -5. I don't know how much is this clear, but we're basically making the 4 of them positive. It's possible we can put them, like if we have 5 negatives, we can put them somewhere, this 2 in the array, in the matrix, somewhere this 2 in the matrix, and then we end up with this one, right? This one, if it's -5, it's better that we make some other value that is smaller than the absolute value of 5. So it's 1, for example. There was 1. We can make it -1. How do we do that? So we choose, for example, if let's say there was a -5 here, right? Let me actually go back. Let's say there was a -5 here. It is possible. So this 2 is already next to each other. We can make them, that's what we want. We want to put the negative values next to each other. So we can make them positive. This will be positive and positive. Now we have -4 and -7. It is possible to put them in pairs. So we can do, how we can do this? This is negative and this is positive. One way to do it is just choose this two pair. We make this positive and this negative. So basically we would make this positive and this one negative. And then choose this 2 and choose this 2. Basically make this one negative and this one positive. And then we would choose this 2, right? And then we would make it negative. We would make this negative and this positive. We have now -2 and -8. Somehow we changed certain stuff, but what we're focusing on is this -7 and -2. We have 2 negative values in adjacent, so we can make them positive. So we make them positive. So you see, we had 5 negatives. We had 5 negatives, and we now have only one negative. It's -5. So we don't want this -5 here. We want something greater, a negative value. So if there was a -1, we would take this one, right? There is a case that we could end up having a -1 instead. So there was a way that if we go back, so we make this positive, but then we could choose this to make this negative and to make this positive. Basically, this could be a positive value. This could be a negative value. Did we have a negative? This was positive, I guess. This was positive. So now we have positive and -1, and we could make this one. Okay, we actually did what we did. There was a negative value and -4. I guess. Okay, things get a little messy. Let's get back to it now. I thought that we didn't have -4 at first, but we had it somehow. Okay, now we have -5 and -4. We can end up having -1 actually instead of -4. So we can choose this -5 and -4, and then we'll have 5 and 4. Then we can choose this -1 and -7. So at the end, you can see now we have only -7, but we can change it to a smaller value. We have only -7 at the end. That is the only negative value right now. But let's just swap it with, what I mean swap, we just swap the signs. So basically, let's choose this. Okay, let's choose this -7 and 1. Make this a +7 and -1. And we can always choose this -4 and -5 to make them positive. So at the end, we only have -1. There is, like, if there was 0, we could somehow swap this -1 to up to 0. So if there's somewhere 0 here, so somewhere in your array, if you have -1, because since 0 does not have a sign, it does not really matter if you count it as negative or positive. If you have this -1, and if there is even a smaller one, which would be 0, then you can swap this negative up to this 0. If there now you could bring this, basically this negative value, by doing the operation. By doing this operation, but since we only have this negative value, all the remaining elements are positive, and so you would do the operation on a pair where one element is negative and one element is positive. So -1 and positive. So basically, you would just take this negative and bring it to the next to 0, and then you would apply this on this pair 0 and -1 to make it positive, and 0 would not be negative or positive either. It will just stay 0. So basically, when you have at the end, so now we have -1 since we do not have any way to improve it. If there was 0, we could do that. I hope you get the point. It gets a little observation at this point. When I explain, I might got lost. So we had basically at the end, if we made all the elements negative, and you end up having a value, let's say previously was -3, and you end up with this -3, right? So if in the array, if there's a positive value, that is the only negative value you end up at the end, because other values could always be put in pairs and make positive. And you have -1 at -3 at the end, and all of the values are positive here. You can just drive this negative value through this positive values next to this negative, this where here, let's say, or here, -1, negative, and then you can choose any of this pair to make this one negative. So then you would have this 3, and all the remaining elements stay positive, and you just bring this -1 negative here, this negative sign, on to -1. So every time basically you take when there are odd number of even values, uh, when there are odd number of negative values, at the end you want the remaining negative value to be greatest as possible. Like in this case it's -3, but it is possible to bring this negative value basically to this right next to this 1, so we can end up with this 1, and this would be +3. Now actually let's see the code. This was quite messy, and it was more of a mathematical trick. I wouldn't say mathematical trick, but it's an observation based problem. But it's a really a good problem that you can learn a lot. But please, after you solve any problem, the learning starts after you solve it. If you said, okay, I solved it somehow and struggled and whatever, in any way you solved it, maybe in 3 hours or 4 hours, it doesn't really matter. Like the only thing that matters is that you observe what you did while solving the problem. Just learn the patterns after you solve the problem. That is one of those problems. Because the next time when you feel like this, when you're stuck on a problem and your idea does not work, then you can say, okay, I was in a similar scenario, and that is what I did. I shifted my perspective. I pursued another idea. So do not get stuck on that, and ask why you were. Now, if, for example, you were stuck on this problem, ask why you were stuck. So in this kind of problems, when you do some sort of operation and you have to do it in an optimal way so that you can have a maximum or a minimum something, there's some kind of extreme value, right? In this kind of problem, it's sometimes hard to see the optimality, what you have to do, what is the optimal case, what elements should I choose to apply the operation. In this kind of problems, then look for an observation, look for a trick. There might be like a sort of a puzzle for you. It's hard when the optimality is hard to see. Look for a simpler case. Start from a simple values. Like imagine that just like we did with think about only a single negative value in the matrix, and we said that it is not possible to make this one positive. So we can make this negative smaller, and we can make this negative bigger so that it contributes to the sum the most. And we did this sort of observations. Well, while you might get lost, but that's fine. That's how you learn at the end. Okay, now let's see the code. The code is quite simple actually. We have count, basically what we said. We want to count the negative value. We have the min. This minimum is the minimum of the absolute value of elements in the matrix. This is basically the one that we want if in case of odd value. In case of odd number of even negative values, we want the less negative value to be this the minimum. So we basically go through every value. If this is negative, we count it and add the sum to we just add the absolute value of this value to the sum, and we take the minimum with the absolute value of this element. And at the end, if we said, okay, we have even number of negative value, then we can put them in pairs. We can put them in a group sort of way, like so that they're next to each other, and then we can choose in pairs and make all of them positive. So that's why the sum is equal to the sum of the elements in the matrix in positive. So since we take the positive values, the absolute values of every element. And otherwise, if it's odd, we just basically get rid of this negative value from our sum, whatever end up being the largest negative value, and then we choose basically we replace this negative value. We just bring this negative value to the one that we choose at the end, and then we return the sum. That was hard actually, and I hope you learned something from this. I have actually some recommendations for solving problem, maybe I'll make another video for that. But that's all for this video. See you in the next videos.